Hi, everyone. Sophie said, my name is Janine Keith. I'm a senior engineer here at the National Laboratory of the Rockies, and I am here to talk to you today about SAM, the System Advisor Model. So when you're thinking about an energy generation system, there are a lot of complex questions that you need to answer, especially when it comes to financial feasibility. The cost effectiveness of a system can be impacted just as strongly by the details of your financing structure or your revenue agreement as it can by the costs of the equipment itself. And so that leads to some really complex questions that must be answered before a project or sometimes even a research idea can move forward. And that is where the system advisor model comes in. Complex questions like that require detailed models to give answers. As a quick overview of what SAM is, the System Advisor model is a free software that enables detailed performance and financial analysis for a variety of types of energy systems and financial markets. It's available in several different formats, a desktop tool for Windows, Mac, and Linux, as a software development kit, which includes our popular Python package called PySAM. The code itself is open source with extensive documentation and user support, and it's typically updated approximately annually with new capabilities and features. You can download it freely yourself from our website, which is linked, and there will be another hyperlink at the end to show the address. Originally, SAM was started to be developed in 2004 as a joint project between the U.S. Department of Energy, the National Laboratory of the Rockies, and Sandia National Laboratories originally. And the vision back in 2004 was to allow DOE to identify the strongest research and development opportunities based on the analysis of the entire system, including the costs, not just the technological benefits. They also wanted to be able to model different types of renewable energy projects in a single third-party validated impartial platform. And we wanted to facilitate technology comparison by handling performance costs and financing consistently across different technology types. Since then, there have been 22 years and counting of continuous development of the system advisor model. Some of the notable advancements that has included has been a slew of new technologies over the years, many new financial model options, linkages to a whole host of related data sources and tools, some built-in advanced analysis capabilities to extend the ease of answering complex questions from within the tool, a variety of new features and expanded capabilities, specific features that were directly funded by outside companies. And then more recently, it has also included open sourcing the code itself so that all of the underlying models can be viewed easily by the public, and wrappers for multiple programming languages so that the tool can be extended. And all of that has led to a tool that can now answer a variety of different kinds of questions. I've pulled out some highlights of the types of questions that folks use SAM to answer here. It includes, how should I design my system to perform best in this specific location that I'm considering? What would a potential power purchase agreement revenue be if I operate storage projects in different ways? Or relatedly, how soon might I need to replace my battery depending on how I dispatch it? There's also more on the behind the meter side. How would a particular incentive or utility rate structure impact the payback period for different kinds of systems that homeowners might install? Or even the research side, where how will my R&D project improve a technology's cost effectiveness? Or how does the net present value compare for different technologies in my location? And lastly, what might the trade-offs be between more efficient, expensive equipment and less efficient, cheaper technology? So as I said, this is a selection of the types of questions that the SAM tool can be used to answer. And you'll notice that a lot of them are really combining detailed look at the technology side with details of the financial structure itself. We do that by having the model structured, regardless of the technology you're looking at, in the following way. We think of it as two big parts. The first part being what we call the performance model, which is more technology specific. Regardless of the technology you're looking at, you need information about weather or resource data. You need information about the system specifications for the type of system you're designing, and any losses that the system is going to experience that aren't explicitly modeled in the tool. Combining those things allows you to calculate a lot of more of the performance side of the outputs, including hourly or sub-hourly power production, capacity factors, operating characteristics, things like that. Where the power really comes in is when you combine that with the second half of the model, the financial models. And for that, there's information about the costs of the system, obviously, any incentives that a system might be eligible for, whether that's at a local, state, or federal scale, how you're financing that system. Is there a loan for larger scale systems? Are you looking at debt service coverage ratios? And then lastly, your compensation structure, which for larger scale systems might be selling power directly to a utility through a power purchase agreement or participating in energy markets. Or for smaller systems on a commercial building or someone's home, that would be offsetting electricity that you would otherwise be purchasing from the grid. And when you combine those aspects with the performance model, you can get a lot of really powerful outputs, including net present values, levelized costs of energy, payback period, detailed operating costs, information about revenues, tax implications, etc. And you'll see that I do like to highlight in this structure the top and bottom green arrows, the costs and the compensation, used to be strictly inputs to the financial model. But with storage technologies, whether that's electric battery storage or thermal storage, the costs and compensation actually are also fed into the performance models to make the most intelligent choices about dispatch based on revenue options. And we combine this model structure with the technology and financial model availability for a variety of different technologies and financial models. We include a variety of different storage technologies, concentrating solar power, photovoltaics, industrial process heat, marine energy, wind power, fuel cells, geothermal power, solar water heating, biomass combustion, and what we call a generic system, which is more of an input your own energy generation profile to be able to combine it with the financial model. And then we also model hybrid systems that combine multiple generation and optionally multiple storage types as well. And a lot of these models are available with a variety of different financial models. So as I mentioned, the larger scale systems that might be selling power directly to a utility are typically governed either by a power purchase agreement, where we have several flavors that have different tax equity implications, or what we call merchant plants, which are participating directly in energy and ancillary services markets. There's also a variety of what we call behind the meter financial model options. So for folks who are offsetting their own electricity usage rather than selling something back to the grid, including residential, commercial, or third-party owned systems as well. Having this model structure for a variety of different technologies and financial model markets has led to quite a bit of usage of the tool across multiple industries and sectors. We like to share some of the usage statistics that helps motivate us to continue adding features to this tool. The SAM desktop tool is started once every 1.4 minutes around the world with more than 280,000 registered users. One of the things we believe strongly on the team is that if you create a great tool but don't teach anyone how to use it, it's maybe not as helpful as it could be. So we also have a variety of webinars and videos with over 600,000 cumulative views. And we have various industrial large commercial partners as well. Enphase, Southern Company, EPRI, etc. SAM is also used extensively in research. So on the bottom left-hand corner here, I'm showing a graph of citations that feature SAM in a research paper as tracked by Google Scholar over the years. So you can see we started tracking back in 2009, and we have recently hit a cumulative total of over 10,000 citations of SAM. So it is impacting a lot of research and development areas as well. And on the lower right-hand side, we do some tracking of the usage of the desktop tool specifically. About half of the tool starts are coming from the United States and about half internationally, although people who are using the tool might be modeling systems outside of their own geographic region as well. I also like to mention that in addition to being its own end-use tool for external users or internal users, SAM is also a foundational building block for other models, including some models that if you have been on any of the other Powered by webinars, you might have seen. So SAM helps power a variety of other tools also at NLR, which you can see I've listed a few of in the row in dark green here. There's a model that looks at consumer adoption of different technologies called DGen, which uses SAM to create energy production profiles. It feeds into grid modeling tools such as Reeds and Sienna, which I know have done some of the Powered by webinars. It also feeds into hybrid modeling tools, including tools like H2 Integrate and the Behind the Meter Modeling Consortium that looks at combination of behind the meter technologies and electric vehicle usage. And those tools run larger scale analyses that result in journal articles or technical reports for anything from city scale to nationwide studies. And SAM is playing a foundational role in those to create energy production profiles, inform battery dispatch and financial feasibility, and more, for a variety of different types of studies that I list a handful of on the right, including grid modeling studies, net present value of breakthrough technologies, utility rate analysis, technical potential studies, and collaborative research with industry. And that's in addition to the top row in red, SAM's impact on the industry that's using the tool directly to look at specific systems, including engineers, developers, utilities, as well as installers, monitoring platforms, etc. And this foundational role that SAM plays is made possible by having a design for extensibility. So we have the desktop application that I've mentioned, which is how many people access and use the tool, particularly when you're looking at analysis for a specific site. And that has some built-in advanced analysis features, including being able to parametrically sweep through different input options, doing some stochastic modeling where you might add uncertainty onto the input values themselves, probability of exceedance modeling to take a look at your financial uncertainty potential, as well as a built-in scripting language and a feature that we call macros, which allow people to extend the usage of the desktop tool easily and then share those extensions with other folks in their company. But we also provide a software development kit in a variety of languages. The most popular right now is our Python PySAM package, but you can see there's a whole list of other programming languages through which folks can access the SAM model. And that is how many of the other models that call SAM repeatedly access the SAM tool, including models that are written by industry partners who use SAM to provide some of the base calculations for technology performance or financial decisions, and then focus on their own value add features on top of that. And lastly, I'd like to highlight that the SAM code, as I mentioned, is open source on github.com, which provides sort of the pinnacle of collaboration opportunities that are very easy with industry, flexibility of the tool because folks can take it and modify it to behave the way that they wish, and transparency into what calculations is SAM doing. So with that, I like to switch to a few different selections of example analyses that folks have done using SAM. This isn't an exhaustive list, but I tried to pick sort of a breadth of types of analyses to demonstrate the types of things that the tool can power. The first one I'd like to highlight is actually projects at the National Lab of the Rockies, where we are analyzing geothermal cost and feasibility using SAM. So many analysts internally use SAM to benchmark the costs of different geothermal technologies using some fairly detailed geothermal cost models that have been implemented in SAM, as well as to calculate the net present value of the current state of various different geothermal technologies. These products commonly are distributed through the NLR Annual Technology Baseline, which provides some insight onto the current and projected future states of different costs of different technologies, including the very popular enhanced geothermal systems that have been added into SAM as well. SAM is also used jointly by NLR and DOE to evaluate research and development plans for the DOE geothermal program. So that's an example of one of those questions I highlighted earlier. If I have a new idea for an innovative piece of one of these technologies, and it's more expensive, but it's also going to give better performance, what does that look like for the cost effectiveness of the technology as a whole? And that's the way that SAM is used for internal R&D questions in the geothermal space. We also do quite a bit of research in the battery space right now. The SAM tool has fairly robust models for battery performance at a detailed level, as well as a variety of what we call heuristic dispatch algorithms. So rather than being an optimization of how the battery should dispatch, it's a bit more rule-based. Think of your thermostat at home, where you're telling it when you would like the heat to be on and when you would like it to be less warmed up or less cool in the summer as we are now. It can be as simple as that, or it can be a bit more complex where it's looking at projections of the technology performance, the electricity load for a behind the meter system, and the costs of a given utility rate. And internally, we have used these features recently to help quantify how much uncertainty there is in a typical estimate of the utility bill savings from installing a PV plus battery system on your home. So put a different way, if you are getting a quote for PV and battery on your house, for example, and the battery installer says that the battery savings will pay back the cost in about 15 years, how accurate is that estimate? It turns out that the answer depends pretty heavily on your utility rate type, which I won't dig into in great detail here, but I will point out that there is a link to the presentation that my colleague Brian gave recently. And we are anticipating a journal article associated with this, which is underway right now. But the reason that we like to highlight this type of study is that quantifying the uncertainty that is present in these estimates may lead to better modeling techniques to improve the estimates of savings, which would allow homeowners and businesses to make more informed decisions about whether they want to install energy storage or not. As a bit of a different kind of an application of SAM, I pulled out an example of one of those foundational models, as I mentioned. So NLR has a tool called the Renewable Energy Potential Model, REV, and the calculations of technical potential across wide geographic regions are sort of the specialty of this tool. I've pulled out a few different images here from different studies, which I have linked. But what these are both doing is basically showing what is the potential generation for different types of systems across, in this case, the continental United States. REV does a great job adding in a lot of information about costs and site suitability and distances to transmission lines and things like that. The underlying generation profiles for a particular technology are created using SAM from within the REV platform. And finally, I've pulled actually an external example from an energy developer, Bechtel, that used SAM to answer some very detailed questions. I actually borrowed these slides from a colleague of mine, Rick Holtz, with his permission, that he gave at a presentation just in May, so pretty recently, looking at PV plus storage hybrids and a variety of questions that they had that they used SAM to analyze, including what was the best way to configure the plants, how should the plants themselves be dispatched, which off-taker or revenue structures made the most sense for those particular systems, what combinations of capital costs, operating costs, tax incentives, and power purchase agreement prices support financial success, and what energy capacity and ancillary services should the plants address with the energy storage. I won't go into the full results here, but suffice it to say that we were very impressed by Rick's use of SAM. He dug into every feature that the tool has, as far as assessing the financial model capabilities, the ancillary market participation, varying costs, varying how the energy storage was coupled to the PV system. It was a really very thorough analysis. And as the development team, we love to see these types of uses of SAM as well, where folks are really using the powerful engine to dig into the details of complex questions. So I feel like it wouldn't be fair to do all that talking about the tool and not at least show you a screenshot of what it looks like. So I have that included here. I'm showing here what we call the results page within the tool. So SAM itself is set up with a variety of default values for every input to make it a little bit easier to use and to provide some guidance for inputs where users might not have an estimate of what that value is going to be. We use a variety of data sources to come up with those inputs. But one of the key features that enables is that you can actually open the desktop tool, click the simulate button down at the bottom left-hand corner without changing a single input, and take a look at what types of results the tool can produce, as shown here on the summary page. There's a selection of performance metrics. There's a selection of financial model metrics, including net present value, internal rate of return. And I happened to include a screenshot of a hybrid system that combines PV, wind, and battery. And it shows you the generation that each of those types would produce, as well as the round trip efficiency of the battery with the way that we've chosen to operate it here, as well as a few default graphs of the energy produced by the wind part of the system in the sort of very colorful looking graph, and the PV part of the system in the much more daily patterned heat map that you can see on the bottom sort of center. And this is just a selection of outputs. We have a variety of other webinars, as I've mentioned, that go through the tool in great more detail. If you're interested in digging into using it, those are a great resource. But I'll also highlight we are actually fresh off of a new release. We just released version 2026.7.3, which is correlated with the date where we released it. It is the birthday version for one of the developers on our team, so we like to sometimes pick fun dates to release. And so we encourage folks to check it out if they're interested. And as I mentioned, you can download the tool for free at sam.nlr.gov/download. And we look forward to hearing what everyone here would like to do with the tool. With that, I will go ahead and take any questions that may have popped up. And thank you all for your attention. I'm looking forward to interacting with you a bit more. See, I'm digging through the chat a little bit. I see Matt has answered some of the questions, so I may highlight a few of them. One person was asking about prices for electricity in a utility rate that vary every 15 minutes. Well, I suppose it doesn't specify whether it's a utility rate or a market price. But the answer is yes. So for a front of meter, SAM can handle sub-hourly pricing, where you can feed in time series of prices to sell your electricity against. And behind the meter, I believe that is also the case, as long as you're providing the information for what that price structure looks like. And the other note that I will make is that it's also required to provide 15-minute weather data in that case. Although there are a few macros included in SAM that allow you to downscale an hourly weather file to 15-minute. Obviously, it's not as robust as having 15-minute data because each point in an hour will look the same. But yes, SAM does provide sub-hourly calculations for a variety of different technologies and financial scales. That's one of the areas where we see it adding quite a bit of value, particularly as the world is evolving to a much more time-based regime. I don't know, Matt, if you had anything you wanted to add to that, or if you had other questions you were going to highlight.
No, I think for that one, I think, yeah, that's kind of what I was trying to convey in the chat, but thank you for following up on that. I did have one that I marked to answer live from the Q&A. I think it'd be good to get your perspective on. So this is an anonymous question, and I would encourage whoever submitted it to follow up with us afterwards. But the question is, we are building a service that provides independent solar and battery feasibility studies before a customer chooses an installer. What is the best way for a small company to use SAM to create clear, reliable, client-ready reports?
Oh, that's a great question. And that is definitely in line with one of the intended usages of the tool. We find that a lot of people who want to extend SAM in their own value add tool like this use our software development kit. Most popularly the Python package, but obviously there are a lot of different wrappers depending on what your application is written in. We had a recent collaborator integrate SAM into their Rust platform, for example. And that is one of the intended uses of the software development kit, is for commercial entities to use our sort of base level performance and financial estimates and then focus on your value add features. So that would look something like getting familiar with the software development kit, which we usually encourage people to actually start with the desktop tool to get a good sense of what it includes, what variables you can change and what they mean, how they would impact the results, and then move from there into calling those same models programmatically. I'll also mention that we have an active support forum on our website where there are quite a few questions about integrating the software development kit that you can search for folks who have asked similar questions in the past, or you can also post your own question, and we do monitor that and answer questions as well to support folks in getting the software development kit integrated into their tools. It is available with a very permissive license for commercial purposes, so there's no worries there. And one sort of useful feedback tool to us is to hear more about how folks are integrating the tool and the challenges that industry doesn't feel like they can tackle on their own. That tends to be where we like to propose projects. And additionally, we've also had actual contributions from this type of user as well, where folks want a new feature added or a new sub-model type, and people have contributed directly to the open source code. And in the majority of cases, we do integrate those contributions, which makes SAM better for everyone. So that's another sort of bonus of interacting with us on more of the programmatic side.
Cool. Thanks, Janine. Questions are coming in fast, so I'm going to start handing more off to maybe answer live.
Perfect.
So we got through that one. Is there a tool in SAM to design and analyze green hydrogen production plants?
Oh, a great question. There's not currently an explicit model for green hydrogen production. We have actually hacked SAM in the past. So one of the other fun things about being a SAM developer is that I like to call us experts in using the tool for things it's not specifically meant to be used for. So we have done some projects in that space to take a look at how different types of renewable energy systems might produce hydrogen, or have, sort of a decision between selling to the grid during high market prices and then using to produce hydrogen during low market prices. Those were some interesting projects to look at. There are other tools at NLR that look a little bit more at hydrogen production that I think if someone was looking at analyzing that would be worth checking out, although it is an area of interest for us as well. It's probably a good point in time to talk a little bit about the evolution of the types of technologies available in SAM. Is a little bit driven historically by interest in those types of systems from the United States government, and those typically who need a tool to analyze the technology and financial feasibility of a technology do end up looking at SAM. And so things are added not necessarily in a let's say, not necessarily in the path that we always decide. Sometimes there's interest from someone else in adding a technology. And sometimes we decide we would like to add one and we go actively pursue funding for that addition. So hydrogen is more in that latter bucket of something that we're interested in, don't have yet, but there are some other tools at NLR that you could leverage.
Okay, next one from Michael Paterno. Sorry for pronunciation on that. How would you model a standalone battery energy storage system selling the power to an aggregator like Voltus?
Oh, great question. We recently added the standalone battery option to SAM, I believe it was a year or two ago, because we knew folks were interested in looking at these standalone systems that are just, doing energy arbitrage, market price arbitrage. And so I would say that currently there are some ways to hack a little bit how you're looking at selling power to an aggregator from within the SAM financial models. That's also an area where we would like to make those features a little bit more streamlined and usable for that, or virtual power plants, et cetera, other agreements like that. We do have a variety of features where you can input time series, both time series dispatch and time series prices. So that's probably one of the more robust ways right now to look at the what if scenario for selling power to an aggregator, is to get some historical data for that aggregator and take a look at how the battery energy technology that you're looking at would have performed in those historical scenarios. That's similar to what we recommend for folks who are looking at what we call merchant plants, or plants that are participating directly in energy and ancillary services markets, is either to use historical data that's available from some of the utilities as far as time series, market, and ancillary service prices, or there are some resources at NLR that we're also integrated with that look at future projections of what time series prices could look like.
Next one, I'm also happy to answer as well as ask, but I'll ask it for the sake of the recording because geothermal is popular. What geothermal processes does SAM cover, i.e. EGS, hydrothermal, single well closed loop, question mark? Can it be used for geothermal storage? And what are the geologic inputs / analyses?
Oh, good. I'm glad we have Matt on this call because he's our geothermal guy right now.
Yeah, so currently we model geothermal both hydrothermal and EGS resource, and then those can be either a binary power plant or single or double flash plant. Um, Continuing to work with the experts at NLR on the geothermal model development. Lots of good updates coming, and updates on reservoir modeling are in the pipeline, doing some more advanced kind of reservoir modeling there. We don't currently model geothermal storage, although that is another one that's on the wish list. In some of our concentrated solar power models, there is thermal storage. So 2 tank, 1 tank, I think those kind of solutions for thermal storage, but we do not currently model the underground thermal energy storage. So, but that is a wish list item. And I cannot speak to the geologic models so much, but we do a lot of active work in the geothermal area. So great that we got this question from Robert. Next one, a little confusing. It might be a good opportunity to talk about some of the advanced modeling capabilities, parametrics. From Rashid, if I want to forecast the long run system-wide cost reduction from a percentage decline in battery storage costs, say from a successful R&D breakthrough, what is the right approach to update the battery costs slash performance inputs in SAM, get the new capacity mix and total system costs? Can SAM
Okay.
do that?
I think I understand what you're asking. Um, It sounds like a question about understanding what the impact of a battery storage R&D breakthrough would be on sort of system-wide deployment and costs. And the answer there would be that SAM does a piece of that. As you mentioned, you would modify the cost assumptions for capital or operating costs to reflect what you think the cost reductions for the R&D project would be. And then also obviously modify the anticipated performance accordingly for that innovative new concept. And then once those sort of cost predictions and profiles are created with a tool like SAM, they're generally fed into more of then a grid modeling tool to understand the impact in a broader sense of what that R&D project might be. So at NLR, those are tools like Sienna or Reeds that take a look at production cost modeling for a whole system or capacity expansion and how different cost assumptions might impact the mix of generation types that are predicted in a given grid scenario or the cost of operating, a grid-wide uh, system with those R&D pieces. So SAM is a part of the equation, but usually those larger grid scale tools are how one then understands what that impact would have on a more broad grid level scenario.
Great, yeah. We have a PySam question from Boston. Is there any means to change the heat transfer fluid using PySam? Would you make a webinar on the topic of using PySam for custom simulations? So I think heat transfer fluid here is probably referring to a CSP question, which is always tricky to model. So I definitely would say before, Janine, you can give your input. We are always happy to help, especially with some of the PySam setup. It can be a little tricky. So we're always happy to take some of those questions probably in more detail over email, or maybe you'll show some of those links at the end, but I think they'll be available in the material as well.
Yes, yeah, that's definitely a great question. There is some information on setting up the PySam inputs on the forum as well. So I would search for some of that. The heat transfer fluid, I can't say that probably Matt or I know right off the top of our heads what that Python input would be. But in general, most things that you can do in the desktop tool, you can also do in PySam. Um, and one of the things that we do typically recommend for people who are picking up the PySam tool uh, is to actually also download the desktop tool and take a look at the user interface for the technology you're interested in. In this case, it sounds like a CSP model. You can take a look at what inputs are available, what they're called, what sort of the default values are, and what options are available. And then you can actually export the code as an example in a language of your choice from the desktop tool. So for example, you could set up a CSP system exactly the way you want with a custom heat transfer fluid. And then you could export that code from the case itself. There's videos on our website of how to do that. And that would show you what those inputs look like and what the values are to set up the way that you're interested. We find that a lot of people benefit from approaching it that way because as a detailed tool that answers complex questions, SAM does have a lot of inputs that are available. And so sometimes setting up the case that you're interested in the desktop tool gives you sort of the benefit of being able to see a bit more of the help documentation, the descriptions, of different inputs, and then that can make it easier to jump into the PySam model.
Great. Yeah. Sticking on theme from Michael again. Is there a help desk that I can reach out to when I get stuck modeling a battery? Or yeah, just talk about some of the help options.
Yes, absolutely. As I mentioned, one of the things that our team believes is that a great tool isn't so helpful if people can't use it correctly. So we have a lot of resources on that front. On the SAM website, sam.nlr.gov, there are a variety of resources along the left-hand side sorted by technology. So you can check out the battery technologies. There are links there to a lot of historical webinars that we've given, which give helpful overviews of different markets. So I think there's webinars for utility scale batteries and behind the meter batteries, if memory serves correctly, that give a bit of an overview of the features available. Within the SAM desktop tool itself, there's also extensive help documentation. In the upper right-hand corner of the tool, there's a help button, and that help button will bring you to the help topic for the input page that you're looking at. So say you're looking at the battery lifetime page and you're not really sure what you should be inputting, that's a great time to take a look at what help has to say on the topic. And it will give you descriptions of the input types. It will provide links to some of the underlying studies or reference papers that might be helpful where we have them. And then the sort of third line of defense is, as I mentioned, the SAM website has a forum where there's pretty active asking and answering of questions. It's searchable, so you can see if anyone else has asked a question like yours already. And if not, you can add a post, and we do monitor that forum and provide insight. Sometimes other community members will also answer questions on the forum. And as sort of the last line of defense, if there's proprietary information or something you don't want to post on the website forum, we can be contacted by email as well, and those details are on the website. So that's sort of an overview of the ways that people frequently interact. We also do end up sometimes collaborating with different entities who are using SAM or writing new models to extend capabilities. So we have a variety of different collaborations that we have done in the past with software companies, with utilities, with research institutions. And so if you have an idea for collaboration, we're always happy to chat with you as well on that front.
Yeah, I'll take the next one quickly, and I'll kind of combine it with a couple of questions here. The anonymous question, does SAM currently support geothermal and wave energy projects, and can it compare their cost and financial returns with solar and battery projects? And then a question from Austin, similar, can we make simulation of geothermal, solar, and thermosolar, which I'm going to take to mean concentrated solar power with SAM? Yeah, that's one of the good things about SAM is we have all these different technology models, and we typically like to say like compare them in the same financial consideration, so the same financial model, and you can kind of do that apples to apples comparison of different technologies. And then to at a high level, we mentioned geothermal, we've talked about solar. We also do model wave energy projects and also tidal energy projects. So that's another performance model that can go with all the same financial capabilities as well. And we also currently do have the wave model paired with the electric battery. So that's also a modeling option for some of the financial models. So that's one of the big benefits of SAM. I did want to make sure I wasn't missing anything in the chat. From Peter, Janine, I don't know, you have a comment on this. Do you have offshore wind data, and if so, where?
There are some connections to wind data resources that NLR has created. Off the top of my head, I believe that there is at least one offshore resource, but I could not tell you where. And there may be other resources available. So I'll take the opportunity to more broadly say that when you're looking for resource data, regardless of which technology you're taking a look at, we have made some attempts to provide the ability to download information about that resource from within the desktop tool where we can. But we also have a sort of generic CSV format that resource data can be read in. So if you have external sources of data, for example, there's maybe an offshore wind data source that you have and like, but it isn't coupled with SAM. Or in a lot of cases, folks will have information actually from a resource measurement campaign that has been run somewhere. Those resource data can be used in a SAM simulation simply by formatting them in the appropriate resource file format and then pointing SAM to where that file is on your machine. And there is information on the website about how to set that up, as well as in help about what those files should look like, what features they need to include, so what types of measurements need to be present in the file for a simulation to run, et cetera. So I would say that there are some automated linkages, and if there's other data sources that you like or want to couple with, that's an option as well. And then I do see a question in the chat about the battery side of things that I can answer. It's from Daniel. Can you elaborate on how estimation of future prices is modeled or given as an input in SAM today? And is a battery operation modeled assuming a price taker, or is there something considering grid level needs for the operation? That's a great question. So the price assumptions for batteries are an input in the tool. So you can provide something that's structured like a present utility rate or time of delivery factors agreements in a power purchase agreement, or you can provide time series market prices for a plant that's going to participate in an energy market. And you can provide those either for a single year or for the lifetime of the system. If it's a single year, though, they repeat with optional escalation on those values, so sort of increasing with inflation, for example. Or you can specify how they will evolve over the lifetime. So we're not necessarily modeling how the prices themselves are going to change, but rather what the financial feasibility of a system would be given a certain set of prices. But there are a lot of ways to get those prices in there as different types of agreements. And then as far as the price taker or grid level needs question, it's a bit of both. So primarily the financial models in SAM are considering revenue from an agreement to sell power to a utility purchaser. But there are also inputs that allow you to provide values, say, for capacity payments or ancillary service payments. And depending on which financial model you're using, different features are available. So there's a little bit of both, but SAM is not looking at the grid as a whole to determine what those capacity payments would be or what those ancillary service values would be. That's sort of the line where SAM is taking, grid level considerations as an input and saying, what does that do to the financial feasibility of my specific system? Some of the other NLR tools that I've mentioned are the ones that are frequently calculating, what are the scenarios of the grid level capacity payment values or energy prices, et cetera. So we do have a link to an NLR resource called Cambium that we sometimes use for some of those future energy and capacity payment scenarios. Or one can also use historical data that is available from utilities, et cetera. I hope that answers the question.
Sorry, handling a few more questions, but
oh yeah, go for it.
From John Bleem. Hi, John. Does the new version handle different escalation rates for buy versus sell prices during the analysis period?
That is a great question. That is a detail I don't have stored in my head. So if you would like, we can follow up afterwards with what the answer to that is, or you can check it out and let me know what you find.
I think the best answer is probably, without having looked at it, is that you can always do like a custom time series buy and sell line. You might just have to calculate it yourself and put it in like an hourly format or whatever the time step is. But you can always have like a custom array of different buy and sell rates on the utility rates. So it's always an option, and it might just require a little bit of extra work on your end, but
I wanted to also highlight another question I saw where someone was asking about uh, quickly visualizing the different results. For example, if you were to change your battery size on one diagram. I saw Matt gave a great answer in the chat, but that's one that I like to highlight broadly as well, is that we have a capability that I mentioned built in called parametrics, where it allows you to set up a case in quite a bit of detail and then pick a few inputs that you might be interested in varying. So in this instance, battery size might be the input that you vary. And then you can pick an output that you sort of want to screen those scenarios with. So you could change your battery, to 2, 4, 6, and 8 hour batteries. And how does that impact my net present value of the system? And that's something that you can definitely do quickly in the parametrics tool. That sort of was our vision when we were implementing it, was that people do frequently have questions like that. And we wanted to give people a quick way to run sort of those sizing sweeps or input sweeps to take a look quickly at, here are a few design choices I'm considering. What's going to have the best impact either on my annual energy production, my net present value, or any of another variety of outputs that are available.
cool. Moving back to the Q&A, because I think we got through the chat. Another anonymous question that I'll tackle on geothermal. What information would a small company need to collect before using SAM for a geothermal feasibility study? So I am not the subject matter expert on geothermal, but from working in the models, I can say the minimum information you would need is information on where your resource is, like in the depth and temperature you're expecting at that resource. So wherever the reservoir is planned. There's some NLR data set that's publicly available, I think, with some of that information, or there's also external data mapping as well. And then from there, you would probably need to know information, some preliminary information on what type of power plant you're looking at, binary or flash, whether it's a hydrothermal or planning for an EGS resource. And then either the total system capacity you're looking at for the power plant or how many wells you're planning on drilling. You can model it either way. And then from there, we have cost models, performance models to go from there to kind of give you a preliminary idea of your results. And also, you can look at different impacts of how successful you are in drilling, because not every well is going to hit the resource. So you can look at some of those sensitivities as well. Um, but yeah, definitely follow up with us if you have more questions about geothermal, and we can connect you with all the experts. So. From Russ, where is the financial input data derived from, and can the financial numbers be modified?
Great question. Yes, so pretty much everything that we can expose to users, we do on the financial model side. So whether that is what the system costs are, what the taxes are, what the tax rates are, the terms of your debt, your incentives, et cetera, all of those are available as inputs and can be modified. As I mentioned, we do provide default values. The majority of those where we can source them do come from the annual technology baseline, which is linked in the slides, which will be distributed after the presentation. And that sets sort of reasonable values for different technologies at different scales, for what the costs look like today or what some of the financial model structures are. Sometimes the information is pretty robust. Sometimes the information is a little bit limited. It varies a bit depending on the technology itself. But we attempt to set all of the inputs up with reasonable default values. That said, should you have better information for your own system, you should definitely overwrite them. All of the inputs are available to tweak things in a bunch of different fashions. So yeah, taking a look at what your own specific costs are, your revenue structure, your tax implications, et cetera. All of that can be tweaked to best represent the detailed finances of your own system. And then Sam does create cash flow pro formas for almost all of the different financial markets, with the exception of the one very simple calculator that we have in there, mostly for internal usage. So you can really look in great detail at what some of those financial parameters are doing to your cash flow over the lifetime of the system.
Sorry, I was looking something up. Last question I'm seeing at the moment, also anonymous. Have you thought of including technologies with CCS for an apples to apples comparison with technologies in your current set? Based on context, I'm assuming that's carbon capture, but
Yeah, I would make the same assumption. We don't currently have any carbon capture capabilities. We don't have any in the current pipeline.
great. Barring any last minute questions, it seems like we answered everything. So
Well, and great timing because we have just 2 minutes left, which is enough to thank you all for your attention today and for a slew of great questions. That's my favorite part of a webinar usually, because that way we can make sure that we are actually providing the information you guys are looking for. So thank you again for your attention, your great questions, and we look forward to hearing how using the tool goes for you, or possibly collaborating with some of you in the future. And thank you also, Matt, for your great job jumping in on a lot of the questions and wrangling all of the questions in that box. Thank you all.